Hi, this is Professor Gina, and I'm going to do a series of videos talking about section 7.5. The focus here is solving trig equations, and there are a number of different techniques, and so I'm going to do probably 3 different videos increasing, 2 or 3 videos increasing the level of difficulty. So we'll start with some of our simple equations. We want to find, oops, that's not what I want. Find all solutions to the equation sine of x is equal to the square root of 3 over 2. So this is a value that's on the unit circle. And typically whenever we have a trig value that we're considering, unless it is one of the angles that's on an axis, then we'll always have 2 possible solutions. So we know that one of the solutions for sine being a positive value shows up in the first quadrant. So we have one solution here at pi over 3. And then the other quadrant where sine is positive is in the second quadrant. So we have another value here at 2 pi over 3. Now that would be the 2 solutions if we were only looking between 0 and 2 pi. Or between 0 and 360 degrees. But this is asking us for all solutions. And so what we do is we think about what the period of that function is. The period of sine is 2 pi. So what we're going to do is that we're going to say that our solution is going to be every iteration of pi over 3 and then adding 2 pi. So as we go around the circle multiple times, we'll be at pi over 3 and then we'll go around the circle again and we'll grab another value. And then we can go around the circle again and grab another value. So the solutions for this are going to be pi over 3 plus 2k times pi, or 2 pi over 3 plus 2k pi, where k is any integer. So examples would be k is plus or minus 1, plus or minus 2, plus or minus 3, etc. So all that means is that we're going around the circle either clockwise or counterclockwise, depending on which value for k we add, but we always stop at one of those 2 points that we found as our solution. That would be the solution for radians. The solution in degrees, this is in radians, would be 60 degrees plus k times 360. I guess I could write it 360 degrees times k, or 120 degrees plus 360 degrees times k. So that's just 2 different options of how to put this. I'm giving you both solutions because in my math lab, sometimes they'll ask you for degrees, sometimes for radians. Most of the time in calculus, you'll be asked to give your answers in radians. So that was our first example. Okay, for our second example, let's find all solutions for cosine of x is equal to -1/2. We know that cosine of x is negative in quadrant 2 and quadrant 3. So that's where we're going to find our 2 solutions. Thinking about the unit circle, cosine is -1/2. Here, it matches the first example that we just did, and then also here. So this value is 2 pi over 3 here. And then down here, we're at 4 pi over 3. So our solutions in radians is going to be 2 pi over 3 plus 2k pi, or 4 pi over 3 plus 2k pi. And then the solution in degrees would be 120 degrees plus 360 degrees times k, or what is that? 240? No. Yeah, 240 degrees. Oops. Plus 360 degrees times k. And again, k is any integer. In this example, we added 2 pi or 360 degrees again because the period of cosine is also 2 pi. Right? That's what the distance is before it starts to repeat itself again. Okay, for our third example, we're going to look at tangent instead. Find all solutions where the tangent of x is equal to -1. Well, tangent is negative in quadrant 2 and also in quadrant 4, right? And we know that the tangent is equal to 1 when we're at 45 degrees. We know that tangent is going to be, it is 1 there, right? So that means that over here and over here, that's where tangent is -1, and also over here. So I think that my solutions are going to be that's 3 pi over 4. And then also that's 7 pi over 4, isn't it? But we can combine these two solutions because we know that the period for tangent is pi. It repeats every 180 degrees. And these two solutions here are a distance of pi apart, or a distance of 180 degrees apart. So what we'll do is we'll write our solution in radians. As 3 pi over 4 plus pi times k. Because adding, when k is equal to 1, it's going to grab that second solution of 7 pi over 4. So we can grab all the solutions just in this way. The solution, oops. in degrees is 135 degrees plus 180 degrees times k. And k is any integer. All right, so this is the first set of examples that are fairly simple. Let's switch to a couple different examples that are a little bit more complex. Hang on. Let me. Okay, for our next set of examples, the the equations are going to be a little bit more complex. This is example number 4. Let's find all solutions, and we'll have either within the range of 0 to 2 pi, that will be for radians, or for degrees, it'll be between 0 degrees and 360 degrees. And our equation is going to be cosecant squared of x minus 4 is equal to 0. Now, in the last set of examples, we were looking for all solutions, and so we were adding these iterations of 2 pi or 360 degrees. In these cases, we're only going to find the answers that are in the ranges that are given. So let's start by moving that 4 to the other side. And then we'll take the square root of both sides. So when I take the square root of both sides, I need to remember that I always get 2 possible solutions for a square root. So I get that the cosecant of x is either equal to positive 2 or negative 2. Now that we've simplified this, let's switch cosecant into its reciprocal function. Let's switch this into sine. So I have 1 over, the sine of x is equal to plus or minus 1 over 2. Take the reciprocal of that side. So where is sine equal to 1/2? Sine is equal to 1/2 here and here. And then for negative 1/2, it's here and here. So these values are pi over 6, 5 pi over 6. This is 7 pi over 6. And this is 11 pi over 6. So those are going to be my solutions. So we'll have that x is equal to pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. Or we can list it in degrees. That's 30 degrees. That's 150 degrees, 210 degrees, or 330 degrees. Okay, I'll do one more example on this video. Let's find solutions in 0 to 2 pi or 0 degrees to 360 degrees for cosine squared plus 2 cosine equals 3. When I look at this, I see that it's maybe having the form of a quadratic. So I'm going to move that 3 to the other side. When I solve a quadratic, I always want to get everything on one side, 0 on the other. And then I'll just, over here as scratch work, I'm going to do a variable exchange. Let's let m equal cosine of x. You always consider that term that's in the middle. So what we would have is something like m squared plus 2m minus 3 equals 0. I'm just changing it into a format that might be a little bit easier for me to factor. This factors into m plus 3 and m minus 1. So then I'll split this into 2 equations, either m plus 3 equals 0 or m minus 1 equals 0. So m is -3 or m is equal to 1. Now going back to my original variable, m is, we put that in the place for cosine. Cosine of x equals -3 or cosine of x equals 1. Well, for this first example, this right here is not possible, right? We know that cosine has a maximum value of 1 and a minimum value of -1, so that we're going to reject this possibility over here. On the other side, cosine is equal to 1 only when we're at 0 degrees or 360 degrees, 0 or 2 pi if we're in radians. This is in degrees. This is in radians. But when I look back at the original, the way that our ranges are set up for the solutions, 0 and 0 degrees is included in our possibilities, but the 2 pi and the 360 degrees are not. We've got a rounded parentheses. So for this case, we're just going to accept these two answers only. So our solution is going to be x equals 0 or 0 degrees. When we write 0 in this way with no degree symbol, this is a radian measurement. Okay, that's my first set of videos, and then I'm going to make another set in just a little bit. Thanks for watching.